How's it going? What up? What up? What up? Yo. How we all doing on a fine Tuesday? It's a little cloudy, but that's okay. That's okay. You can still go into your backyard, breathe in the fresh air, enjoy life. That's what we need to do. Enjoy life while we're staying safe and making healthy decisions, but we should be enjoying life. How we all doing? How we all doing, chat? We got a first, we got a last, we got a rip. What else we got going on? Let me guess. The delay is 1,000,000 hours long. Someone say something, please. Not good. What's not good, sir? You're not feeling very well? What's up, Bob? Staying alive, Cream? Good. You should be staying alive. We should all be staying alive. What's going on, Alexis? There it is. The coughing dab. Right? Right? That's what's going on. Emerald TNT King. All right. Well, I'm glad everyone's doing well. Let's see how many views. 15 viewers. Guys, it's 11:45. We should be waking up, ready to go. I appreciate all of those that are here. What great, diligent, well-rounded students who want to learn and do well. Proud. All y'all. There it goes. There it goes. It's no longer called the dab. It's called the cough. You guys are funny. 18 viewers. Yeah. People are waking up. They're coming out from their slumber. They're waking up from their 3 a.m. playing video games in the middle of the night excursion. Can't do that anymore, guys. I used to be able to. I used to be able to stay up for 2 days straight and just play video games non-stop. But now, 11 midnight rolls around. I feel like death. I want to die. So I go to bed. And you should be going to bed too. All of you guys should be going to bed at a good, decent time. And on top of that, we're all trying to stay healthy, right? Getting enough sleep at the appropriate time makes us healthy. Makes our immune system stronger to fight off whatever infection and disease comes our way. So let's get right into this. Let's start this. So last night's lesson in 10-2, we talked about the arithmetic and geometric sequence. Let me pull up that lesson just so I can go to the definition page. Ba, 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 ba. All right, so for the arithmetic sequence here and geometric sequence, basically what I said was that whatever our value is on our sequence, we're adding this common difference every single time. Meaning we're adding or subtracting this number. So it's going up or going down by an equal amount. Then, for a geometric sequence, it's going up or going down by okay. Sorry about that. It's going up and down by what we call a common ratio, which means that it's being multiplied by a number. And it's either increasing or decreasing by that multiplied number. So, in us being able to find what they are, what we should do is we should look at the pattern of the sequence, and then based upon that pattern of the sequence, we can watch Tiger King. Oh man, my wife wants me to. We should just take a look at the pattern, and then that'll help us determine if we're either adding a number or multiplying by a number. That's going to be the same every time. So number one, I have 1, 4, 9, and 25. So here it's increasing by 3. Here it's increasing by 5. Here it's increasing by, what is that, 16? Well, it's not increasing by the same value every time. It's not being adding 3, or adding 5, adding 3. It's not being multiplied by the same number, because this is times 4, and then from 4 to 9. What? That's definitely not times 4. So it's neither. This is neither geometric nor arithmetic. Let's look at another one, and then we'll look at some questions. So on number 1 for this piece here, so we have 3n minus 5, and that's from n equals 1 to infinity. So it didn't write out the sequence for us, so we need to spend the first step writing it out. So plugging in 1, 3 minus 5 is negative 2. Plugging in 2, you get 6. 6 minus 5 is 1. Plugging in 3. 3 times 3 is 9. 9 minus 5 is 4. Plugging in 4. 3 times 4 is 12. 12 minus 5 is 7. So that's enough. Usually about 3 terms is going to be more than enough for us to be able to determine that. And so from negative 2 to 1, I'm adding 3. I'm adding 3. I'm adding 3. Okay, well, it looks like I'm adding 3 every single time. So therefore, it's going to be an arithmetic sequence. All right, so any questions on those two that I just did? Yeah, Tiger King, I hear, is pretty darn insane. Amazing. Thank you. The sarcasm. All right, let's look at number 3. So 1/3, 1/6, 1/12, 1 over 24. Well, adding from here to here, I would have to find the common denominator, but it doesn't look like if I'm getting from a third to a 6, it's getting smaller. So I would be like subtracting a value, like subtracting a 6. But then if I subtract a 6, again, I get 0, not 1/12. So I'm not subtracting a number here. From 1/3, well, it's the 1 to 1. Okay, so that means if I multiply by 1, I'm still going to get 1. But from 3 to 6, if I multiply by 2, so if I multiply by 1/2, I get 1 over 6, okay. If I multiply 1/2 here, I get 1 over, oh, there it is. 6 times 2 is 12. And if I multiply 1/2, 1 times 1 is 1, 12 times 2 is 24. So I'm multiplying by 1/2 every single time. So that's going to be geometric. Questions on that one? Okay. I think we all just woke up and we're slightly sleepy. Not a whole lot of chat going on. Or we're all playing video games while we're watching. Caught y'all. All right, number 5. So 17, 5, -7, and -19. Okay, well here I subtract 12. Okay, so that's good. And then from 5 to -7 is subtracting 12. Creeper? You're a creeper, bro. -12, or -7 minus 12. That would give me -19. So I'm going down by -12 every single time. So that's going to be arithmetic. Any questions with that? So like I said, to determine if it's either arithmetic or geometric, which you're going to do, there's a typo. Yeah, I'll do number 4. So arithmetic, we're adding in a value or subtracting a value every time, same value. And then with geometric, we're multiplying by the same value every time. Where's the typo, Bob? Number 4 twice in the worksheet. Number 4 twice on the worksheet, huh? People. I'm just kidding. I fixed it later. I caught it. All right, so we're going to write out a few terms. So plugging in 1. So I get 3 times 1/5 to the 1 minus 1, which is 3 times 1/5 to the 0, which is going to be 3. No, Bob, I fixed it later. I just didn't fix it on the other worksheet. N equals 2. Then you get 2 minus 1. So that's going to be 3 1/5 to the first. So 1/5 to the first is going to be 1/5. So that gives me 3/5. And then the n equals 3. I'm going to get 3 1/5 to the 3 minus 1. Which gives me 3 to the 1/5 squared, which is 3 times, and then 1/5 squared will be 1/25, which is 3/25. And then n equals 4. 3 times 1/5 to the 4 minus 1. And that's going to be 3 times, and then 1/, so 5 times 5 times 5 is 125. So that gives you 3/125. All right, so now let's write them out. So 3, 3/5, 3/25, and 3/125. So from here to here, it's going to multiply by 1/5. From here to here, it's going to multiply by 1/5. From here to here, it's going to multiply by 1/5. Divided by 5, divided by 5, divided by 5. And so therefore, since it's by 1/5 every single time, I know it cut off just a little bit. I'm sorry. There we go. So because of that, it's going to be geometric. Now, in this next lesson, the 10-3, just know that this is what the form of, or not next one, but the one after, that's the form of a geometric sequence. So just know it's all the same. And then we're going to recognize that, oh, that looks like a geometric sequence because it's based on the form. But we need to be able to know how to determine arithmetic or geometric based on the pattern. That's essential. So that's why we did that first. And then we're going to learn the different forms. All right, comments or questions on that before we move on to the new section? So before we move on to the new section. Oh, and as a reminder, while we're all just kind of chilling and waiting. Yeah, no problem, Lexus. There is no live stream tomorrow. I will update the online information to correspond with that. Long story short, they are opening up San Dimas for us teachers to go get things that we need to go get. It is a very small window in which they're open to go get the things that we need to get. And so that small window actually happens to be dead smack right when the streams are. So I don't know how long I'm going to have to be there. I don't know how long I'm going to, because I'm going to have to search my classroom and grab stuff because I have to upgrade grade books and all that different stuff. So, yeah, I just didn't want to put pressure on me having to rush. I didn't want to put pressure on you guys and, oh, let me message. I'm going to be 30 minutes late. People are waking up. People need to plan. So let's not worry about it tomorrow. Next stream is going to be on Thursday. All right, so let's look at number 6. So log base 117. I will go over 9 to 12. No worries. Okay, so for us to be able to cancel the log, we're going to take base 117 to both sides because the logs are on both sides. And so I get 1 minus 3x equals x squared minus 3. I'm going to talk about Alex in a little bit. I will answer that question, Takashi. Now, once we're here to this 1 minus 3x equals x squared minus 3, it's now just a quadratic equation. So we solve it like we would a quadratic equation. Add 3x minus 1. So I'm going to get 0 equals x squared plus 3x minus 4. So that factors into x plus 4, x minus 1, x equals negative 4, and positive 1. Now you have to test these because extraneous solutions. So we have to plug them back in. If I plug back in negative 4, am I going to get a negative inside my square root? Well, 1 minus 3 times negative 4, that is 13, positive 13, so we're good there. If I plug in a negative 4, that's 16. 16 minus 3 is positive, so negative 4 is one of our solutions. And then with 1, if I were to take the 1 and plug it back in, well, here I get 1 minus 3 times 1. Well, that's negative 2 inside of my log. I can't have a negative 2 inside of my log. So because I can't have a negative 2 inside of my log, That can't be one of my solutions. So x equaling -4, that's my only solution for the log. I will do number 8. I will go over 8, and I'm going to go over 9 through 12. Questions on number 6 before I move on? This delay, I wish there was no delay. The awkward pauses. All right. I'm going to do number 7 and the number 8. So with number 7, I'm just going to set both of them up, and then I'm going to let you guys finish them because it's just quadratic stuff. So log base 6 of x plus 4 plus log base 6 of 3 minus x equals 1. So with the log, we have to condense it. Yeah, that's the window. It's 9 to 12. Okay, so that log base 6. So multiplying them, I get log base 6 of x plus 4 times 3 minus x. That's going to equal 1. Take base 6 to both sides. So I get x plus 4 times 3 minus x. That equals 6. It's quadratic. You got to multiply all this stuff through. Dot, dot, dot. And yeah. Any other questions with number 7? Now number 8. Now with the log on both sides, what I can do is I can get the log to one side. So I can bring it to the other side. So I'm going to get log base 2 of x plus 3 minus log base 2 of 6 minus x. And then that's going to equal 3. So if I bring this entire logarithm over to the other side, now that it says minus, I can take those logs and I can condense them together. And so I'm going to get log base 2 of x plus 3 over 6 minus x. And that's going to equal 3. Does that answer your question, Janelle? So now I can take base 2 to both sides. And so I'm going to get x plus 3 over 6 minus x. And that equals 2 to the third. 2 times 2 times 2. So that's going to be 8. And then to get the x out of the denominator, I'm going to multiply by 6 minus x on both sides. So that'll cancel out there. I'm going to get x plus 3 equals 8 times 6 minus x. Dot, dot, dot. I'm sure you guys can solve it from there. Just remember, because it's a log, you're going to have to take it and you're going to have to plug it back in to test. Yay! Interesting. I just went over to my YouTube dashboard and it says that my latency is normal, but in my Streamlabs it says it's low. That seems to be the issue. As to why there's a delay, I'm going to look into that. There might be a test stream later tonight while I try and work that out. So don't be alarmed. Okay. Moving on to number 9. So for number 9, it is an inequality. So because it's an inequality, that means that we have a number line, and I'm going to have to test it on a number line, and we're going to do all that different stuff. So break it up into 2 equations. It's absolute value. So to solve an absolute value, so I get 7x plus 2 equals 10. That's the positive version. And then the negative version, negative 7x plus 2 equals 10. So now solve for each one. So minus 2. Divide by 7. X equals 8 over 7. That's 1. The next one, distribute the negative. That is correct. When you test them, you cannot have a negative or a 0 inside of the logarithm. That is absolutely correct. And divide both sides by negative 7. So I'm going to get x equals negative 12 over 7. So those are my 2 solutions, but now I have to test them on the number line. So on my number line, negative 12 over 7 and 8 over 7. Open circle because the inequality does not have an equal to. And now I need to test. So the values I can test here is negative 2, 0, and why not positive 2? You're welcome, AJ. So if I plug in negative 2, negative 2 times 7 is negative 14. Negative 14 plus 2 is negative 12. The absolute value of negative 12 is positive 12. 12 is greater than 10, so this is true. If I plug in 0, 7 times 0 is nothing. Nothing plus 2. So 0 plus 2 is going to be absolute value of 2. 2 is not greater than 10, so that's false. And then positive 2, 7 times 2 is 14. 14 plus 2 is 16. 16 is greater than 10. That is true. So the shaded region here is my solution. So that's going to be from negative infinity to negative 12 over 7. Union from 8 over 7 to infinity. Comments or questions on that one? Okay. Next one. Let's look at number 11. Number 10 is just quadratic. I think number 11 is going to be the good one. So this one is the absolute value of 3 minus x is greater than or equal to x minus 5. So once again, just because there's x's inside and outside the absolute value, doing number 11 right now, Cora. Bam! Look at, knew exactly what you were thinking. So just because there are x's both inside and outside the absolute value does not change the definition. Sometimes our brains think it does, but in this instance, it's not going to. So we still need to break that apart to get rid of the absolute value. One positive. So whatever's inside the absolute value is positive, and then whatever's inside the absolute value is negative. Now, because it's an inequality means number line, I have to test true or false, it's a shaded region, etc., etc. But to get rid of that absolute value, you break it into those two values, the one positive and one negative. So now solving for x in this, 3 minus x equals x minus 5. I'm going to add x. I'm going to add 5. That cancels out. That cancels out. So you're going to get 8 equals 2x. Divide by 2. You get 4 equals x. Now in this one, if I subtract x's, well, then I get negative 3 equals negative 5, which that entire thing is false. So now, let's check this solution to see if it's true, because that could tell us a lot here. If I take this 4 and I plug that in, absolute value of 3 minus 4, is that greater than or equal to 4 minus 5? So absolute value of negative 1, is that greater than or equal to negative 1? Uh-oh. Is that true? Is that false? What is that? Sorry, equal. Equal. Can it equal it? The reason why, because it says greater than or equal to, so I have to validate the equal to. Can the equal to even work? And so in this instance, 1 cannot equal negative 1. So this is not even a solution. And if I want to do a number line, there's no values to put on a number line. So I have to test if the entire number line is going to be true or false. So if I pick 0 and I plug that in, I get 3 minus 0 is greater than or equal to x minus 5, or 0, sorry. 0 minus 5. So I get the absolute value of 3 is greater than or equal to negative 5. That's true. Well, everything is true. Every single value for x that I can pick is going to be true. Now, that's my assumption. Let's take a look at Desmos. So we're going to take a look at the two graphs here. I have the absolute value of 3 minus x, and then I have x minus 5. Now if you notice, this red function, and I'm going to move it over here, this red function, that's the absolute value of 3 minus x, and the other function, the blue one, is the x minus 5. So the question is, where is my 3 minus x bigger than my x minus 5? Now, in this entire graph, the red graph is higher than the blue graph, higher than the blue graph, higher than the blue graph. Everywhere on the entire function, the red graph is higher than the blue graph. So that's why everything was shaded, which means that my answer is going to be from negative infinity to positive infinity. Now, this type of weird stuff, because I'm going to be it, this is a weird problem, only happens when you have x's both inside and outside the absolute value. This is when weird stuff like this can happen. And the reason why 4 didn't work was because nothing crossed. And if you look at this graph here, nothing is crossing this graph. They don't intersect at all. Right? This might be, maybe, I don't know. Like, they don't even intersect. That's where we thought they intersected. Was right here at 4. But remember, absolute value, instead of this going all the way through, it stops here and then goes above. Comments or questions on that? I know it's a weird problem. All right. Well, if that's the case, that's the assignment. Went through the majority of it, which is good. As a reminder, there isn't going to be a stream tomorrow. So I will see you guys all on Thursday. Look to the, because that, that online document that they sent to every student that has all the teachers and stuff on it, that's going to get updated probably sometime tomorrow. So go ahead and take a look at that. One thing that I will be creating here soon is a Google Classroom, and it's going to give you guys the ability to upload the work that you guys did. So I can give you guys credit and stuff for that. So for the Alex, we're going to kind of pause Alex right now because, so here's the weird thing, right? The work that we're doing over this, it can't affect you, right? So that's kind of like the weird thing about this. So if I did Alex right now, there would be like it can't negatively impact you. So I'm thinking of some ideas on how I could use Alex to positively impact you guys, if that makes any sense. So I'm gonna take a look at the averages, the rest of the what's going on with Alex. I'm gonna see if I can create something that's gonna be suitable, something that's gonna be equitable, something that's gonna be worth it for you guys. So there's no Alex right now, just because of that. So just kind of stand by on that. So the 10-3, I'm not going to go over the DI for that until Thursday. So I'm going to do a live stream every DI unless otherwise stated. I know I said I'm not going to have a live stream tomorrow, but just know that, you have tomorrow off in math. Tomorrow off, right? So you could watch it still tonight. You can watch it tomorrow. But just know that on Thursday, we're going to do 10-3. Did I answer everyone's questions? Woo. Great. Well, you know where I am. You guys can hit me up on Discord if you guys do have any other questions. Have a good one. Stay safe. Make healthy decisions. Um, Practice social distancing, but you know, backyard, get some fresh air. Depending on what city you live in, some walks are okay as long as you maintain a safe distance from people. But we got to get outside. Got to get rid of that cabin fever. Got to get that fresh air. So don't forget to do that. I'm taking my dogs on a walk. Just be safe and practice that social distancing still. But don't just sit in in your room playing games all day. You got to get out and got to get some fresh air. So, alrighty, we're good, guys. Thanks. I'll see you all Thursday.